Day 417 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2200. Find all k distant indices in an array. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given a zero-index integer array nums and two integers key and k. A k-distant index is an index of I or index I of nums for which there exists at least one index j such that I minus j is less than or equal to k and nums of j is equal to key. Return a list of all k-distant indices sorted in increasing order. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure we're doing this problem correctly. So in example 1, we have the input nums equals an array of integers 3, 4, 9, 1, 3, 9, 5. The key is 9 and k is equal to 1. Our output is an array of integers 1, 2, 3, 4, 5, and 6. So let's go ahead and look at these explanations just so we could make it make sense and understand how they got this output from this input. Boom. So first thing the explanation says, it says here nums2 is equal to key and nums5 is equal to key. That is important because when we're looking for a k-distant index, one of the requirements is nums of j has to be equal to key. So now we know that if we know nums2 is equal to key, so we could use that as a nums of j, and nums5 is equal to key as well, so we could use that as a key as a nums j as well. So let's look. Key is 9, so once again we have a 9 at nums2 and we have a 9 at nums5. So let's keep going. So it says for index 0, 0 minus 2 is greater than k, and 0 minus 5 is greater than k. So there's no j where the absolute value of 0 minus j is less than or equal to k, and nums is equal to key. So thus 0 is not a k-distinct index. Now, that may seem a little bit confusing at first, but we have to remember that these right here are talking about the indexes themselves. They're not talking about the values of the indexes, right? So nums, when it's like this and it has num square bracket j, that's when it's talking about the value of the index. But right here, just the 0 and 2 and the 0 and 5 is talking about the index itself, the number of the index. Talking about index 0 minus index 2, or 0 minus 2 is going to give us negative 2, which is the absolute value is greater than 1, and 0 minus 5 is going to give us negative 5, so the absolute value is greater than 1 as well, which is why index 0 is not going to work, because we know we have to subtract 0 from 2 because 2 is where the key is at, right? So it goes to index 0, 1, 2. Boom. So 2 is where the key is at, and 5 is also where the key is at. So that's why we're subtracting from 2 and 5. Now let's go ahead and take a look at the next example. So hopefully this will make a little bit more sense as we keep going through these examples. So in the next part, it says for index 1, the absolute value of 1 minus 2 is less than or equal to k, and nums2 is equal to key. So 1 is a k-distant index. So let's break this down one step further. Once again, we're talking about the indexes. We're just talking about 1 minus 2 because we're at index 1. Now we already did index 0, so now we're at index 1 and index 2. So we're just doing 1 minus 2. We're not doing 9 minus 4. We're doing it by the indexes. So it's just 1 minus 2. It's not 4 minus 9, and it's not it's not 4 minus 9, it's 1 minus 2. And when we do 1 minus 2, that's going to give us negative 1. The absolute value of negative 1 is 1, which is equal to k, right? So because k is 1. So it satisfies this requirement. It says a k-index distant index is index I of nums for which there exists at least one index j such that I minus j is equal to k. So in this case, j would be 2, right? Boom, index 2, because right here, nums of j, once again, this is the value is equal to key. So right here, we're doing 2 because that's where it's equal to key. That's where j is equal to key at 2. So that's why we're doing 1 minus 2. That gives us, once again, -1, which is less than k. Boom, or 1, absolute value, is equal to k because the absolute value is 1. So it passes that test. And then nums of 2, the value of index 2, which is 9, is equal to key, right? Boom, because right here the key is equal to 9. So let's keep going through the examples just in case that didn't make sense. So now we're looking for another k-distant index. So we're going to go for 2, index 2. So if we do 2 minus 2, that's going to give us 0, which is less than k. Boom, k is 1, so it fits that requirement, less than or equal to k. And once again, 2, the value of index 2 is equal to key. So the value of index 2 is 9, which is equal to the key. So it says, so 2 is a k-distant index. Let's go to index 3. Index 3, so 3 minus 2, once again, we're looking at the index numbers. We're not looking at the values of the index themselves. So index 3 minus index 2, or 3 minus 2 is going to give us 1. 1 is less than or equal to k. It's equal to k, right? K is 1. And then 2 is, 2 right here. Nums of 2, once again, is equal to k. Equal to the key. Key is 9. We're still at index 2. Boom. Key is 9. Index 2 is 9. So 3 is a valid k-distant index. Now let's go on and find the next set of valid k-distant indexes when j is going to be equal to 9. So in this case, we're looking at index 4. 4 minus 5, that's going to give us -1. The absolute value of -1 is 1. 1 is equal to k, right? K is 1 once again. And nums 5, which is our j, is equal to key. Once again, we have a 9 key. We have key is 9. We have a key at 2 and 5. Right now we're looking at 5. So 5 is equal to key, which makes 4 a k-distant index. Then we're going to do 5, index 5. 5 minus 5 is 0. So 0 is less than or equal to k. Boom, so it fits that requirement. And then nums of 5 is 9, once again, which is equal to the key. So it fits both of the requirements that we're looking for. So 5 is a k-distant index. Then last but not least, for index 6, the absolute value of 6 minus 5 is going to be 1, which is less than or which is equal to k, right? But it could be less than or equal to k. And nums 5, once again, is the key. So 6 is a k-distant index because it fits both of the requirements. The absolute value of I minus j is less than or equal to k, and nums of j is going to be equal to the key. So now we have to return all of these indexes in sorted order, which would be 1, 2, 3, 4, 5, 6 in increasing order, right? So that's how we got this output 1, 4, 5, and 6. Just remember, the two indexes have to fit the two requirements. When we subtract the indexes from each other, it has to be less than or equal to k, and the value of index j has to be equal to key. All of these fit those requirements, so that's why our output is what it is. Let's look at example 2. Example 2, just in case we didn't understand that completely, we're going to look at example 2. Example 2 is a little bit different just because all of the elements are the same, and they're all equal to the key, and they're all equal to k. So in example 2, the output is all of the elements, index 0, 1, 2, 3, and 4, right? So that's why our output is 0, 1, 2, 3, and 4. Explanation says for all indices I and nums, there exists some index j such that I minus j, the absolute value of I minus j is going to be less than or equal to k, and nums j is always going to equal to key because they're all of the values in the array are equal to key. So every index is a k-distant index, hence we return 0, 1, 2, 3, and 4. So just, I'm not going to go too deep into it, but just briefly, As you can see, if we do 0 minus 1, these two indexes, 0 minus 1, that's going to give us the absolute value of that will be 1, which is less than or equal to k. And then this 2 is going to be equal to the key, so it's going to fit that requirement. Then we do the same thing, 1 minus 2. That's going to give us 1 again as the absolute value, which is going to be less than or equal to k. And then this 2 would be j, would be equal to the 2. And same thing if we did 3 minus 4, and so on and so on. So in the end, we could return all of the indexes. So now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution's not that difficult at all. So let's get into it. Now, the first thing we're going to do is we're going to create a constant that is going to store the total number of elements for us. So we could say let n equal nums, nums.count. That's what I'm trying to say. Boom. Now we need a variable that's going to store our final result and list all of the valid indices. So as you can see, our output is an array of integers, so we need to create that array of integers. So we're going to declare a variable called ans for our answer, and it's going to be equal to an array of integers, and we're going to put the parentheses like that. Now we need to create an array, or a difference array, for the range marking the difference between the two indexes. So for that, we could just declare a variable called diff, and we'll set that equal to an array. The default value is going to be repeating, :0, count, count, n plus 1. Just like that. Now we need a variable to store all indices where nums I is equal to the key. So we'll declare a variable called key index, and we'll set that equal to an array of integers, and come outside of that, put the parentheses. Boom. Then we're going to create another variable which will be used to accumulate the difference array. So we're going to declare another variable. We call this one running, and we'll set that equal to 0 just to start. Now, first thing we're going to do is we're going to collect all of the indices where the values are equal to the key. So we're going to say for open up the parentheses, I, comma, v, and nums dot enumerated. Remember, this enumerated is going to get us the value and the index. So in this case, say we're looking at 3, it's going to get us the index, which would be 0. Boom, that's where this I is come from for the index. And then it's also going to give us this 3. So it's going to return 0 and 3. 0 for the index and 3 for the value. That's what the enumerated does. Then we're going to open up the brackets, and we're going to say if v equals key, which is what we're looking for. We want the value to be equal to the key. Then we can say key index dot append, open up the parentheses, or I. Boom. So we're going to append that index. We're not going to append the value. We're going to append the index, because remember, with this requirement, we're subtracting the indexes, not the values. Boom. So then we're going to come underneath this for loop, and if there are no key occurrences, we can just return an empty result. So we can say if key index dot is empty, then we could just open up the brackets and return a blank array, just like that. Boom. Now we need to create so for each key index, we need to mark a range of j minus k and j plus k in the difference array. So for that, we're going to say for j in key index, we're going to open up the brackets, and we need to ensure the left bound is within the array. So we're going to say let left equal max, open up the parentheses, 0, comma, j minus k. Boom. Then we need to ensure the right bound is within the array. So we're going to say let right equal, this time we're going to say min, open up the parentheses, n minus 1, comma, j plus k. Boom. Then we're going to come underneath that, and we're going to start of the range. So we're going to say this is going to be the start of the range. We're going to say diff square bracket left. Come outside of that, we're going to say plus equals 1. Then this is going to be the end of the range. We're going to say diff square bracket right. Come outside of that, and this time we're going to say minus equals 1. Boom. Now we're going to use the prefix sum technique on the diff array to determine the active range. So for that, we come underneath this for loop, and we say for I in 0 dot dot up to n. We're going to open up the brackets, and we're going to accumulate the range. So we're going to say running plus equals diff square bracket I. Come underneath that, we're going to say if if running is less than 0, we're going to open up the brackets, and we're going to say ands dot append, open up the parentheses, I. And that means I lies within at least one valid range. Then we just need to return all of the k distant indices. So we could just come right here, and we could say return ands. Just like that, y'all. That should be all she wrote. Let's give it a run. Oh, almost first try, but not there. Close, but no cigar. Oh, sorry. So I did that too fast. Let's give it some time. Let's run it again. Let's see. Wrong answer. Okay, y'all. So when you get the wrong answer, 9 times out of 10, that means somewhere along the lines, the math is not mathing. And I think it's right here. This should be right plus 1. Sorry, y'all. Sorry about that. So let's go ahead and run it again. See if the math is mathing this time. And it's accepted, y'all. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see. Ooh, look at that, y'all. 100 or 0 milliseconds beats 100% of users. That's what I'm talking about. Those are the numbers I like to see. So with that being said, y'all, make sure you get one more look at the code. This is the top part. Read it, learn it, love it. This is the bottom part. Read it, learn it, love it, internalize it, do what you got to do so you can remember it, because you're going to need to use this stuff that we learned on future LeetCode problems, y'all. So just make sure you understand what's going on. And with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.